Hello everyone, I am Shreyansh and my teammates are Souvagya and Nilesh. Our topic is biomass estimation using underwater images. Our guide is Dr. Geeta Shri ma'am and our coordinator is Dr. Lucky Agarwal. So now moving on to the problem statement. The problem is to accurately measure and classify biomass in aquatic environment because it is important for understanding the ecosystem. Traditional methods are costly, so the underwater imaging technique is a good alternative. This method is also challenging due to variations in lighting conditions, water clarity, and presence of other objects in the images. Now, our objective is to develop a robust method for classifying biomass using underwater images. It should be able to handle variations in lighting and water conditions. It should also be efficient and easy to implement so that it can be used practically in the real world. Now, the motivation behind this is that fish biomass estimation is really important in aquaculture, and this information is crucial to optimize daily harvesting and determining optimal harvesting time.
Okay, so now moving on with the block diagram, it gives an overview of what methodologies we have implemented on this project. We know there are two types of learning techniques, supervised and unsupervised learning. As we could not find any label data because it would require a high definition camera to capture underwater images, we focused on unsupervised learning. Unsupervised learning works on unlabeled data and are fast and efficient. One of such algorithms we have used is k-means clustering. Later on, we have also used texture-featured k-means clustering with Gabor filtering for image segmentation and for giving out better results. By these two algorithms, we have been successful in segmenting living biomasses such as algae, seagrass, and fishes. After image segmentation, using the ratio-based estimation technique on RGB values, we have estimated the number of pixels the living biomasses cover. Next is the architectural diagram, which is divided into three basic blocks, each giving three different outputs. First block contains a seagrass image, which on applying standard k-means gives the result showing classification of the seagrass. Next block contains a fish image with an algae background, and on applying Gabor filtering, we have successfully classified the fish with the algae background. The last block contains an improvised k-means which gives us a better result of distinguishing various fishes with a seagrass beneath it. Now, on comparing with the existing models that has done their work on the estimation of biomasses, we have found that they are highly complex and require much cleaning and high computational power. What we have created is a simple but reliable ML model which can provide us with better results at comparatively lower computation power in less time. This will be useful for agro industries as computers are not complex. Hence, our model can be easily deployed and can give desired results.
So now we will just go through the results. So this was the first image on which we applied the standard k-means. And on the next slide, we can see that here how clearly we can see the distinguishing between the water, which is in the blue color, and the green and the dark green texture, which represents the seagrass. Moving on, we will find the second image, which here we can see that there is a fish, there is a algae in on the ground, and rest water environment. So on this we applied the Gabor filters, and here we can see that algae and fish were properly distinguished from the water, which we exactly wanted. In the third one, uh, we had an image which I will show in the code demonstration, and this is the ratio estimation which we applied on the output from the Gabor filters. So here I have shown three things. We have shown three things. Number of pixels in the total image, that is 234,124, and of this 92,321 pixels are of the living biomass, and the rest are of the surrounding environments. So now moving to the code demonstration. So yeah, this is the k-means clustering, the norm with the uh, enhanced parameters. So here we have imported all the required modules such as NumPy, Matplot, and the scikit-learning. From here, we have imported our image, converted it to the grayscale, and after converting it to grayscale, we converted it we reshaped it as we require it into the 2D as the parameter is required in terms of 2D array. After that, we implemented the clustering with the total number of clusters required as 3. After that, we just gave it to the function, and hence we can see the clustering in our final output. So this is what we received. Now talking of the other one, which is of the Gabor filter. So in this also we imported the images, converted into the required scales, which is of grayscale. After that, the required dimensions, and after that, here we have applied the Gabor filter. As we know, Gabor filter requires two parameters, wavelength and orientation, and those things have been calculated based on the already existing research works. And when we run it, we get the output like this. Uh, it's running, just a second. Yeah. So yeah, here is the output which we got. Now finally is our ratio estimation, which we'll be doing on this Gabor filter image. So basically ratio estimation works like we are trying to we take the whole image, and based on the RGB values, as we know that here the RGB value of water can be easily found out, because in the algae and fish there will be various other pixel values for the green due to light green or dark green, minor variations. So for blue, for the water, we got the RGB value, and on the basis of it we are counting the number of pixels. We took a number of iterations, and we are randomly choosing the points so that we can have a fair share of it. It should not be biased. And finally, when we get the results, it's like what we say. So after, when we run it, just a second, I will run it. And here you can see it's the points which I received. Earlier also, when I run it, you can see that there is a variation in the points. As I said, it is because we are running all of this in a random basis. We are selecting the points on a random basis, so that hence the results can vary, but the variation will be in close proximity. So moving on, yeah. So these are the references and the books which we followed for our project. Yeah. Thank you.